Yeah. So when we have discussed about your game playing strategies, we had two different strategies: min max algorithm. Another one is alpha beta pruning. So min max algorithm was discussed with respect to example like how the child nodes have been allocated some numbers, and with respect to that we will be having level wise. One level is minimum, another level is maximum, and it continues till the end of your tree traversal. In the same manner, the same concept will be again discussed, but to avoid some to save the time complexity or to reduce the time complexity of your uh, approach, we are going for alpha beta pruning. So while traversing with respect to your min max algorithm, we need to visit every node. But once I talk about your alpha beta pruning, it is the modified version of your min max algorithm. That is the betterment of your min max algorithm. That's what we call it as. Okay, 1 second. I can see small window. Yeah. So beta pruning is the modified version of your min max strategy. Yeah, I think this is clear now without any disturbances. Okay, fine. Yeah, so we call it as the optimization technique for your min max algorithm. So yeah, so the main concept here is the complete traversal whatever you have followed through your min max algorithm will be same with respect to your alpha beta pruning, but here we will try to eliminate or prune. Pruning is something like we will be eliminating a part of your tree. So whichever the node or whichever the subtree is not required, we will not traverse through that route or that path, and that's how we will try to make this algorithm better than your min max algorithm. Yeah, here in this technique by which without checking each node of the game tree we can compute the correct min max decision. So there if you want to get the complete decision like which path will be leading to your destination, here we will be trying to traverse to all the nodes, and with respect to some conditions or some constraints we will try to limit our searching process, so that whenever the condition is met we will not try to move for the further nodes, and that's how the time complexity will be reduced. And this can be done with using two parameters called as one is alpha, other one is beta. So whenever we talk about pruning guys, so pruning is something like, so we basically when you are talking about your data mining with respect to your decision tree, so we talk about pruning will improve the searching process, makes searching process more easy. And whenever so when I'm talking about pruning, it's simply like we'll try to eliminate some nodes whichever are not leading to a exact path. Those nodes will not be visited, and that's how we'll try to save some time, and time complexity will be improved. So compared to your min max algorithm, alpha beta pruning will be having less search time. That's why this algorithm is much preferred than your min max algorithm. Okay, yeah. So here the name itself is saying that it's a alpha beta pruning. It's also called as alpha beta algorithm. So here you are having two important threshold parameters. So when I talk about some threshold, it's like a value. Threshold means it indicates a range of some value. So here you are having two threshold values. One is alpha, another one is beta. Yeah, okay. So we'll try to understand what are the conditions and what is this alpha and what is beta in the upcoming slides. Yeah. So alpha beta pruning can be applied with respect to your depth first search algorithm only. As I have said in the previous session, when we have discussed about your min max strategy deals with your depth first and depth fast learning approach. So it doesn't follow a breadth first search approach. It follows a DFS approach. In the same manner, alpha beta pruning also can be applied with respect to your DFS algorithm only. And sometimes it only prune the trees, but also it's not only prune the tree leaves, but also entire subtree. So let's try to understand this concept with respect to example in the upcoming slides. So whenever you are given a tree, it sometimes visits the leaves with respect to your nodes. It not only eliminates or prunes your leaves, it also, if it is not required, a node also can be pruned. That's how alpha beta pruning will reduce your time complexity. Okay, so let's try to understand what actually is this alpha and what actually is beta. So with respect to your understanding, with respect to your examinations or your constraints, you need to explain these two concepts clearly whenever you're talking about your alpha beta pruning concepts. You need to explain about what is alpha and what are the conditions, and what is beta, what are the values you're assigning to your beta. Okay, so let's talk about what is alpha parameter in your alpha beta pruning. Okay, the best highest value choice. So in it, when you talk about your min max algorithm, we talk about maximization and minimization. So with respect to that, alpha is like the maximum, choosing the maximum value in your tree. Beta is the choosing the minimum value in your tree. That's how we'll try to understand, compare these two algorithms. So you need to keep this in your mind. Alpha indicates the highest or the best highest value of your choice we have found so far at the any point. So that's as part of your tree. The tree whatever you are taking in that tree for that node and for that child, comparatively whichever the value is leading to your highest value, that's what's called as the maximized value is called as your alpha. And accordingly, whichever the value is the lowest value, that is called as your beta. So alpha is the range or the value given to the initial value given to alpha is minus infinity, and beta is the plus infinity. That is the value given to your alpha and beta. Okay, yeah. So the alpha beta pruning to a standard minimize algorithm returns the same move. So the algorithm traverses same as part of your min max strategy. So however you're going to traverse with respect to your min max strategy, this also follows the same structure, that is the DFS problem. But the only condition or the only best part of your alpha beta pruning is it removes all the nodes which are not really affecting the final decision. So there are whenever you have been given a tree, suppose I am having some nodes from A to G, and if I want to reach from A to G, I will be having multiple paths, but only one path may lead to less cost, and that will be a best solution. So when I talk about your alpha beta pruning, it will try not to traverse to the nodes whichever are not actually leading to your destination, because it's unnecessarily, if you're traveling all the nodes, that may leads you to lot of cost and lot of time wastage. So alpha beta pruning will try to reduce this concept and will try to eliminate such type of nodes which are not actually leading to a destination. It will try to travel only through a path or a route which will lead to your final destination, and that's how this algorithm will work better than your min max approach. Okay, so you need to remember this word called as pruning. Pruning is simply like eliminating some unnecessary nodes in your tree. So the word pruning basically will be used only whenever you're talking about your tree. Okay, so whenever you're talking about your tree based algorithms or your traversal problems, you need to remember this word called as pruning. Okay, which is eliminating unnecessary nodes. Now let's look at the conditions, what we use for your alpha beta pruning. Yeah, the main condition what we use with respect to your alpha beta pruning is alpha greater than or equal to your beta. So if anybody is just noting out some important points, you need to keep this as an important condition with respect to your alpha beta pruning. Okay. So whenever you are writing your examinations or whenever you are writing any explanations or solving a problem with respect to your alpha beta pruning, you need to keep this in your mind and mention clearly what is alpha and what is beta. As already discussed, alpha is the minus infinity value, and beta will be your plus infinity value. So with respect to that, whenever you are given a tree traversal problem to find the destination from source destination, you will be initially checking these values from minus infinity to plus infinity. The values will be varied, and every time As part of your traversal, this condition will be verified. Alpha is greater than or equal to beta. If not, what should be done? If it is equal, what should be done? That will be discussed in your further slides. So what are the key points or what are the key conditions what we need to ensure while learning about alpha beta pruning? Yeah, the max player will only update the value of alpha. So with respect to your min max algorithm, so whenever you are at the level called as maximum level, that then you only will update the value of alpha. So it will be same with respect, as I said, the traversal mechanism will be same with respect to your min max strategy, but here you will be talking it with respect to your alpha and beta. As I already mentioned, maximized value is called as your alpha and minimized value is called as your beta. With respect to that, the max player will only update the value of alpha. So at the max level or the maximum level, it will try to update the value of alpha, and at the minimum player or the minimum level, it will only update the value of your beta. So these two things should be kept in your mind, because once we talk about your example or once we go to your example, the same things will be seen there. So keep this in your mind. And while backtracking the tree, the node values will be passed to upper nodes instead of values of alpha and beta. Yeah, this point I'll be explaining with respect to your example in the next slide. So we will only pass the alpha beta values to the child nodes. Yeah, this also we'll be seeing with respect to your example. Okay, yeah. So now let's talk about the how this algorithm will be applied with respect to any concept. So previously we have understood min max algorithm also with respect to example, the same example with different values. Yeah, but here the child nodes are having some different values, and with respect to that, on the right side here, you can see in the previous session we have taken the same type of example at level wise. One is maximum, other one is minimum, other one is again maximum, and other final one is a terminal node. Yeah, and here you can see initially the conditions with respect to your a at the root node called as a. The initial values are taken as alpha is equal to minus infinity and beta is equal to plus infinity. That's what is the initial condition of your alpha beta pruning. So initially we will take these values, and once we move forward with respect to your understanding, the alpha and beta values can be changed. Okay, yeah. The first step is the maximum player will start first move from node A. So we need to start from node A and go to node B or node C with respect to your working of your algorithm. And initially values are alpha is equal to minus infinity and beta is equal to plus infinity. Yeah. So now we are moving on for the step 2. So as said, and as compared with the previous approach, here you can see at level 2 it is the minimal value or it is the minimized value. So at step 2, okay, at the node D, you can see the values are 2 and 3. So here we are talking about node D, because the values are allocated to the child node, and we need to compare these values and select the values accordingly. Yeah. So if you want to get the value of your B, you need to traverse these two called as D and E, and you need to get the values from your child nodes. Yeah. Okay. The value of alpha is compared with firstly 2 and 3. Yeah. So here you can see for the node 3, you are having the values of 2 and 3, and you can see the level here. This is your maximum level. So if it is a maximum level, which means you need to take the maximum value of among these two. So among 2 and 3, the maximum value is 3. That's what we will be taking, and the node or D will be allocated a value called as 3, because that is the maximum value. And here above the node D, you can see the value of alpha is updated to 3. So why this has been updated to 3? That's what we have seen in the initial condition. The first condition is here is the maximum player will only update the value of alpha, which means, yeah, here among 2 and 3, the maximum value is 3, which is being taken to your D, and that value is updated to your alpha. Okay, the maximum value will be updated to your alpha. That should be kept in your mind. And again, going on for the upper node called as B. Yeah. So now you can see in here the alpha value is minus infinity, and this is your minimum level. So at minimum level, we will not concern about your alpha value. We are concerned only about your beta value. That's why the value of 3 is updated to beta at B here, because that is the minimum level. Okay. Don't get confused. Once we go to the next steps, it will be easy for you to understand. Okay. So while you're mentioning it with respect to your explanation and examination, you need to mention it like this. Yeah, at step 3, you can see, yeah, algorithm will backtrack to node B where the value of beta will change as this is the turn of minimum. That's what we have discussed. Whenever you're going for minimum level, value of beta will be updated. And whenever you're going for maximum level, value of alpha will be updated. Yeah, beta is equal to plus infinity initially. We'll compare with the available subsequent node values, that is minimum of infinity comma 3. So because basically at the initial condition value of minimum is infinity, and 3, the minimum value is 3, so it is updated to 3. Now let's go for the next step to understand why we should go for the next traversal. Whenever I have discussed about B, you are having two nodes, one is D and one is E, and because it uses DFS or depth first search algorithm, we initially start from your left node then to your right node. Yeah. So in the next step, the algorithm traverses the next successor of B, that is your E node. So at your E node, initially you can see initially alpha is equal to minus infinity and beta is equal to 3. That is at your B. That will be passed to your E value. Now step 4, you can see, yeah, at node E, you are having two values. One is 5, another one is 9. So we have discussed about one important condition with respect to your alpha and beta pruning. That is alpha greater than or equal to your beta. Now let's look about this condition, how this can be applied. Yeah. So at node E, which is the maximum level, you can see here node E is in your maximum level. Yeah, maximum value will be taken and the value of alpha will change here. Why? Because, yeah, the current value of alpha will be compared with 5. So the maximum of minus infinity and 5 is 5, because minus infinity is the lowest value. We need to take the maximum value. That is alpha is equal to 5 will be updated at this node called as E. Yeah, where alpha greater than or equal to beta, so the right successor of E will be pruned. Yeah. So now here comes the concept called as your pruning. So among 5 and 9, you can see the value 9 is being removed, or you can see a into mark, which means we need not visit this value called as 9. Why? Because the condition alpha greater than or equal to beta, that is 5 greater than or equal to 3, is being satisfied. So whenever this condition is satisfied, even though you are having 2 or 3 nodes, we need not traverse that node, because the condition is satisfied. Unnecessarily we need not visit the other nodes. Even though you are visiting the other nodes, it will lead to your same solution. That's why we need not visit the other nodes. This is the advantage of your alpha beta pruning. Okay, according to your condition, if it is being satisfied, we will prune the other nodes. Here you are having the value of 9, so it is being pruned. Yeah, pruned. One second. Okay, now let's look at the other step, step 5. This will be more precise for you to understand. At step 5, algorithm again backtracks to your root node A, because the left side of your tree is completely traversed and we have got some solution. Now let's look at the next node called as node C. We will move for node C and see here at root node the value of A is updated to alpha is equal to 3 and beta is equal to infinity from your previous tree. Okay, so once you are backtracking from bottom to top, the values of alpha and beta will be updated at each level or each node. So with respect to that, you can see your tree here, the values at root node are updated that to alpha is equal to 3 and beta is equal to infinity. Now the same values will be passed to your next node called as C. At node C, alpha is equal to 3 and beta is equal to plus infinity, and the same values will be passed to your again F. From A, the values are passed to your C, and the same values will be passed from C to your F. Okay, now let's look at the step 6. At node F, again the value of alpha will be compared to your left child. Yeah, here you are having uh, F values as children values as 0 and 1. So now we need to take the maximum value from these two because F is in your maximum level. So among these two values 0 and 1 is the maximum value that's been updated to your F value, and compared with the right child which is 1, so maximum of 3 comma 1. So initially the value of alpha is 3 here, but here the next value whatever is updated is only 1. Among 0 and 1 is the maximum that is being compared with your alpha value. But here because alpha value is 3 and the value taken is 1, among 3 and 1, 3 is the bigger value, then alpha value will not change. If the value of f here is 5, assume that f value is 5, then the maximum value will be updated that alpha is equal to 5. Here because the maximum value is only 1, the alpha value will not change. Okay, but the node value of your f will be updated to your 1. That is the condition what we need to ensure. Okay, yeah. So now moving on for your step 7. So here this is one important phase. As I said in the initial conditions, even a subtree can be eliminated if the condition is satisfied. That should be ensured in your concept. Node F will return the value of alpha is equal to 3 and beta is equal to 1. Here you need to ensure this, guys. Beta is equal to 1 is updated. Why? Because yeah, so why beta is updated? Because initially beta the condition here is initially the beta value is infinity and the f value is updated to 1. Infinity comma 1, the minimum value among this one is 1. That's why beta is updated to plus 1. So alpha is equal to 3 and beta is equal to 1. This condition is being applied. Okay, so now because these two conditions are satisfied, even if you are moving for the next node called as G, here you are having the values as 7 and 5. So need not traverse the complete G node because this is where the pruning concept is being applied. Okay, so this is how we will be applying your alpha beta pruning. And if you are traversing, if you are using a min max approach at this for the same concept, the min max approach will traverse the node E with respect to your two subchilds, and it also traverses your G node also. If you are applying your alpha beta pruning, these concepts can be, this pruning can be applied, and this is how we will try to ensure fast progress in your reaching your destination. That's how alpha beta pruning is much preferred than your min max algorithm. Okay, yeah. So now you can see finally step 8, what is the actual path we can ensure. C now returns the value 1. Yeah, here you can see the node value is updated to 1. So among alpha is equal to 3 and beta is equal to 1, you need to check your level, guys. Yeah, so initially we start from max, next min, max, and again min. So among alpha is equal to 3 and beta is equal to 1, the minimum value is beta is equal to 1. That's why beta is equal to 1 is applied to your node C. So whenever a person is evaluating your answer with respect to your question for alpha beta pruning, you need to update the values of min and max at each level. That's how the values will be checked. Yeah, so you can see the value of C is updated to 1, and finally you are reaching to your A. Again the childs of your A are B and C. Among B and C the maximum value is 3 and the root value is taken as 3. Hence, the optimal value for the maximizer is 3 in this example. Yeah, now let's see the actual theme or the actual conditions, how alpha beta pruning is much efficient than your min max algorithm. So I will try to understand with respect to your time complexities, that is ordering of your moves. So move order is an important aspect of your alpha beta pruning. So the effectiveness or why this is the better can be explained with respect to time complexities, as I am trying to put this in your mind from the beginning, why alpha beta pruning is much more efficient than your min max algorithm. Yeah, so here you can see the worst ordering of your uh, worst ordering is big O of b power m, and you can see the ideal branching is big O of b power m by 2. And as you have seen, for every traversal, because of the DFS approach ensured, initially we will traverse from the left and then come to your right. That's how we traverse in your complete tree. So this is the advantage of your alpha beta pruning. So I hope everybody understood the concept of your pruning. So we apply the same concept to your even TikTok toy problem also with respect to your solutions. So all the applications whatever we have used with respect to your min max, the same applications can be applied for your alpha beta pruning for your better understanding or better solutions. Okay. Yeah, so this is what is about your alpha beta pruning, guys. And if any doubts or anything, you can just ask me.